Now we're going to talk about cube performance. A broad spot in developing cubes is when you start to have some performance issues. Number one, people are using it, which is good. Number two, more and more data is being successfully delivered to the client. With this success, you're going to have to look at what can be done to improve the performance. Aggregations are a data structure used to improve query performance for client tools. The pre-calculated data can be used in a different level of a hierarchy because the pre-aggregations are already calculated in the cube. Partitions can separate the data in a fact table to be processed separately than other partitions. Partitions that do not have new data do not need to be processed, thus reducing cube processing time. When designing the data source view, you can use views instead of direct connects to tables from the relational database. This way, the view can be performance tuned by a DBA with better indexing or better queries. Aggregations are built by the attributes and hierarchies defined in a dimension intersected with a particular measure group. You can have multiple aggregations on a measure group, but you should just start with one. The processing gets more complicated with using different parameters for the use of aggregations. It is important to have your dimension properly designed with hierarchies. Make sure you follow the best practices for designing a dimension and use the attribute relationship for hierarchies of the dimension designer. This will help properly define hierarchies. When you build an aggregation, you can select and deselect dimensions to be used. You can use the usage in the review aggregation usage window to apply a different condition than the default. Full means every aggregation for the cube is included. None means there's no aggregations. Unrestricted removes restrictions from the aggregations. And the default is what the designer picks as a default rule, and it lets the analysis services intelligence figure out how best to use aggregations. The aggregation builder lets you control how to estimate the needed aggregations. A certain percentage is found in gaining performance. You can stop it at any time or pick no design. Start with a performance percentage of 30 to 40% and go from there. Usage optimizers let you store OLAP query usage in a table in a relational database like SQL Server. Once queries are accumulated in this table, it means that people are using your cube and the reporting tools are functioning. The results then can be used to define aggregation, just like you saw with the designer. In order to use this option, the General tab of the Instant Properties has to be accessed by a sysadmin to change the log query log settings. Next, we're going to do a demonstration of creating aggregations. First, we'll launch SQL Server Data Tools. You can do this from the icon or from your Start menu. We'll go File, Open, Project or Solution, go to our current folder and open AdventureWorks DW 2014. Next, we'll go and open the cube through the Solution Explorer. In the cube, there are many tabs to perform different options of the cube. We're going to go to Aggregations. Here, you're going to see a list of the measure groups. We'll drill down into the first one, Internet Sales, and go to the Unassigned Aggregation Design and right-click and Design an Aggregation. We'll click Next on the Welcome screen, and the next view will give us a list of the related dimensions in the dimension usage for this measure group. Here you can take the default, fully process the aggregation, remove the dimension by using None, or use the unrestricted. We'll keep the default and click Next. Now it needs an estimate of the number of rows that it's going to find in that fact table. We'll click the Count button, which will give us that estimate in the partition count. We'll click Next here, and now we're given the options to create the aggregation. The first one is when you reach a certain size. We're going to use the second one when the performance gain reaches, and we'll change that to 50%. Then towards the left, we'll click Start. Then you'll see a process on your right of a graph that's looking at the number of aggregations based on how much performance gain you will gain. Here you see 16 aggregations have been designed, and the optimization level is 51%, taking up 53 kilobytes. If you wanted to, you could use that size and use the estimated storage reaches and change this to say 10 megabytes and run again, and it will continue till it finds an optimal aggregation. As this continues, you see how the size is increasing, but the number of aggregations is also increasing, but will level off or reduce based on the amount that is created. It's actually found so far an optimization level of almost 100%. So you can see that 10 megs will not quite get to the largest possible aggregation for the amount of data we have. We'll keep this, click Next, and then give it a name. Once we select Internet Sales, we can either save the aggregation or deploy and process now. The reason you would just want to save it is if you want to create the aggregations for the other measure groups. We'll click Finish, and we'll see what I'm talking about. Here I can go to Reseller Sales, design my aggregations, take the defaults, and get our estimate count. Then go ahead and do, say, a 75% on Reseller Sales measure group, and it'll start creating these aggregations at an optimal level and until it reaches our 75%. Once this one's finished, we won't create any aggregations for sales reason or sales target because there's not a lot of data inside of there. If we wanted to, and we could see that our aggregations have leveled off, we can always click the Stop button and click Next and give it a name. This time I want to deploy and process now. We shouldn't get any errors because we didn't change the structure of the cube or the dimensions. We'll click Run, and it'll process our cube, and the processing has succeeded. We'll close and close our cube, and now we have saved the new aggregations. Finally, with performance, we're going to look at partitions. Partitions help with the performance of processing an analysis services cube. Remember, when a cube processes, it is querying the underlying data source through a query and compiling the data and structure into a cube on disk. Most partitions are created by a date, but it doesn't have to be that way. It could be partitioned by a key value of another dimension. The fact table as a measure group in the cube is where these partitions are created. In our example, we're going to partition by year. The selection of this attribute member can be a lower grain, like quarter or month. The choice needs to be synced with the type of loads being done on the ETL side of the data warehouse. When creating these partitions, you can control the type of processing that is done on each partition. The default is MOLAP, meaning that all the data and structure is processed into the cube. This is the default and makes the processing of the cube longer, but return values from the cube faster. You have to weigh the options with the end users to select the optimal setting. ROLAP means no data is processed into the cube, only the structure. So every time an OLAP query or MDX query is issued against the cube, remember, a T-SQL query will be executed against the database. Use this option with caution even though people want to request real-time data. HOLAP is a hybrid of the above two options where you can try to find a balance with end-user performance versus query return time allowed. We're going to look at a brief demonstration of partitioning. First, we'll launch the SQL Server Data Tools and then open our solution. Next, we're going to open the cube. One of the tabs in the cube is Partitions. First, we'll delete the existing partition for Internet Sales. Next, we'll create a new partition. Click Next in the Welcome screen. In the available tables, we're going to check Internet Sales. Click Next. And now we're going to specify a query to restrict the rows. What we're going to do is grab the order date key, from the query, go to the where clause, and we're going to say order date key is less than 2009-12-31. We'll click the check button to make sure the syntax is correct, and what we've done is create a query for the fact internet sales of all order dates less than 2010. We'll click Next. We'll keep it in the current server instance, and we'll give it a name. Then we'll click Finish. Next, it's going to ask us to do the aggregations. We'll click Next. Next on the aggregate usage, we'll click our count to do an estimation of the count. Click Next, and we'll do a performance gain of 30%. Once we click Start, it'll gain up to 30%. It finds about 6 aggregations. We'll click Next and give it a name. Before we can finish this, we need another partition for the rest of the data. We'll click New Partition. Next on the Welcome screen, select our fact internet sales and click Next. We'll specify a query, go to the where clause, and get that order date again. This time we'll say greater than 2009-12-31. We'll check our syntax. It is correct. And now we have the rest of the data for the fact internet sales. As you can see, you can create an individual partition for each year, quarter, or month using this dimension. We'll click Next. Current server interface selected, and we'll give it a name. It's going to ask us for the aggregations again. We'll click Next and Next, do an estimated count, click Next, and do a performance of 30%. Once that's finished, which it should probably get the same 6 aggregations that the previous partition had, we'll click Next, give it a name, and click Finish. We'll close the cube and save, and then we'll process the cube or deploy the cube just to make sure there are no errors. Now we are able to process individual partitions rather than the full fact internet sales. And you'll see in the processing that it actually does this when you do a full deploy. It'll do each individual partition.